Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas. Get ready, we're gonna have some fun with this. Let's do some math. Unit 32 is titled Grade, Percent Grade, Drop, and Run. There are many units in this math book that you may not use the math in your everyday work very often. But this unit is money. Have you ever been told by someone else the 3 things that plumbers need to know? They tell me this all the time. And every single time they explain it to me as if I've never heard it before in my life. Number 1, fecal matter runs downhill. Number 2, don't bite your fingernails. Number 3, payday's on Friday. And every time they tell me, I laugh at it just like I'd never heard it before, even though, boy, I get tired of hearing it. People will tell that to plumbers, right? These are the things that you need to know. Now, as a code geek, I'm usually like, well, actually, there are many more things that you need to know in the plumbing code. But they don't care about that, right? They're just trying to be funny. And ultimately, let me just point out something that, at least on point number 1 and 2, they are exactly right. 1 being that you have to know how to properly slope a pipe in order to be a successful plumber. That's essential. Every single time you install drainage, waste, and vent pipe, you're using math from this unit 32, where you're putting a slope on a pipe. And, you know, if you're going just using your level as you're grading along, you're probably not doing as much math in your head, but the reality is that math applies, and you are sloping pipe, and you have to slope the pipe. But sometimes it's really helpful and actually time-saving if we do the math. For example, if I'm on an underground and I need to pipe, 80 feet in the ground, I'm going to do the math and figure out how deep I need to dig, because I don't want to have to dig any deeper than absolutely necessary. What about when I'm hanging hangers or drilling holes through joists, and that pipe has to slope? I'm going to do some math. I'm going to make sure that, that pipe is moving up as it moves along. So there are many times when it is to our advantage to use this math, and that's what we're going to go over today. There's different ways to talk about it. It's all basically the same thing. We're going to slope the pipe. Now, let's talk about terms. There are some words that we use that are synonymous, meaning they all are used the same way or mean the same thing, but they're different words. One of them, obviously, is slope, the slope of a pipe. Another used here in the text is pitch. They're referring to the same thing. And another one that is used is grade, and that's right in the title of this unit, grade and percent grade. That one can be a little bit confusing, because when we're talking about finished grade, say on an excavation, what is the grade? We're talking about what is the level, the flat level of the surface, the ground surface. If I say finished grade, we're talking about where is the finished earth going to be around the building. That's grade. Finished grade could also refer to like the finished floor of concrete floor. So grade has actually 2 meanings, but it can be used also to represent slope. So just kind of keep that in mind as we're kicking these terms around. In this unit 32, if I'm using the word grade, then I'm talking about the slope of the pipe and how much that is going to change so that we can have proper removal of waste through the drainage pipe. Let's jump into the text. There's really only 3 paragraphs explaining this thing in the unit, so we can look at that together. But also notice this triangle as we're discussing this. It says horizontal waste piping sewers are installed at a slight slope to carry solids better than would be possible in a true horizontal pipe. I might amend that to say, or not possible. Like when we put in a flat pipe, it's not going to carry waste away from us, right? It's just going to sit in there. So it has to have slope. The plumber measures grade, sometimes called pitch, in inches per foot by use of a level held on the pipe. And that's what we're always doing, right? I mentioned that. You put your level on there. It's going to tell you what the slope is. Away we go. The level may have adjustable foot to give a proper drop for the length of the level. So you can buy those levels that have a little tab that pushes out. And when you do that, it creates the proper grade. What you would do in that case is just make sure that the bubble is level, even between the lines, if you have that little foot pushed down. But I mean, for the most part, I don't even mess with that. I have one of those levels, and it's better to just see the bubble and see where that bubble is supposed to be and make sure that that is adjusted correctly. Look at this triangle. They give us 3 different sides. The top is the run. And we're going to use this ongoing through this mathematics book where we're going to discuss the run, the horizontal distance. The drop, of course, is how far down from horizontal that pipe is dropping as it slopes down. And then they give the diagonal of this triangle, they're calling it the grade. And as I mentioned, we can call that slope. Probably more often in plumbing, we're going to call it slope than grade, but we kick that term around and say, what is the grade? And so it's good to be familiar with those, right? We really don't use the word pitch very often. Moving on, it says the slope of the pipe, sewer, or land may be dimensioned by percent grade. So it's just another way of talking about the same thing, and we're going to play with these different forms of grade measurement or slope measurement. What does it say? A 1% grade is a grade of 1 foot of drop per 100 feet of horizontal run. This is the same rate as 0.01 foot of drop per foot of run, because 0.01 foot is very nearly 1/8 of an inch. 1% grade is equal to 1/8 inch per foot grade. Now, I'd like to prove this to you mathematically and show you how this works. When we're talking about percentage of grade or when we're talking about 1/8 inch per foot, 1/4 inch per foot, what are we really dealing with? Let's have a look at this. All right, let's figure for just a minute the difference between a percentage of 100 and when we're dealing with a foot. What I'm going to do here is just draw out a length. And let's say we divide that into 100 sections. I mean, like, we're going to go cut it all up into sections. I'm not going to take the time to do that. But I would have 100 pieces of that length, correct? Correct. Now, what if I take the same length? And what if I call it 1 foot because that's what it is? What if it is the actual distance of 1 foot? Now I can cut that into pieces, right? I end up cutting that into 12 inches, correct? Correct. 12 pieces. So now I have 12. And then I divide those 12 inches into 1/2 inch or 1/4 inch, or what if I go all the way to 1/8 inch? And that's kind of what we deal with on slope, 1/8 inch per foot or 1/4 inch per foot. But if I'm going 1/8 inch per foot, that means for every inch, there are 8 pieces, right? I've taken that 1 inch, I'm blowing it up here, and I've cut it into 8 pieces. So if I multiply that for the whole length of the foot, I would have 12 inches times 8 pieces, or 8/8 of an inch. And that's going to give me 96. 96/8 of an inch, right? And that equals a total of a foot. Good to know. But what does this have to do with percentage? Well, back here, if I take one little piece of 100, that's 1% of the whole. We can handle that. But if I take 1 little 1/8 of an inch out of a foot, what's the percentage? Well, it's actually 1/96. There are only 96 pieces cut out of this foot when I cut it into 1/8 of an inch. But if we do the math here, it's actually pretty close. Bring in my calculator here. If I take 1 and divide it by 96, look at what I get. It's 0.01 and then 0.4. But if I'm going for a percentage, and this might be a good review for us, what exactly is a percent? A percent is just that part of the decimal to the hundredths place. And if you remember from earlier math, you can convert a decimal to the hundredths into a percentage by multiplying by 100. So if I want to know what percent that is, I would take 0.0104 times that by 100, and all that's going to do is move the decimal place. So I would have 1.04% when timesing it by 100. Now, I might point out that 1% of 100 pieces is pretty close to 1.04% as far as like we're dealing with, right? I mean, if I'm just out there measuring, 1% is pretty close to 1.04%. And that is why when we're dealing with 1/8 inch per foot slope, it's referred to the same as 1% slope. Now, how does that work with 1/4 inch per foot and 2%? Well, if 1/8 is equal to 1%, 1/4 inch is just 2/8, right? We simplify that to equal 1/4 when we do fractions. But 1/4 inch per foot slope would equal 2%. All right, let me throw one to you. What if it's a 1/2 inch per foot slope? What would that be in percentage? 1/2 inch per foot slope is actually 4/8. We simplify that to 1/2 inch, but we would be taking that 1% times it by 4, and we get 4% slope when it's a 1/2 inch per foot. I hope this is making sense. I hope this helps you see that when we're talking about percentages in slope, like 1%, this is why 1/8 inch per foot is equal to 1%, because it's pretty close, right? And there's the math behind it. At the bottom of page 123, we have one other paragraph that describes drainage fittings and the fact that some drainage fittings in the past were created with a certain slope built in. That angle was carved into the old cast iron fittings when they'd tap those and drill the threads into them. They'd put a little bit of that angle in so that the pipe coming out could slope. And that's because, galvanized pipe is very rigid. You can't really force or bend any sort of slope into that if it's coming straight out of a fitting. But the point here, maybe look at fittings were created that way. That's really dated information. I don't know when the last time that you installed a cast iron threaded fitting with some galvanized threaded pipe for a drain. We don't do that anymore. But if you think about the plastic fittings that we do use regularly, the socket or the cup of the fitting where the pipe inserts into has enough space, enough play in there that usually we can create a little bit of an angle and push that to get the slope that we need as we're installing these as drainage pipe. It states in this paragraph that some plumbing codes specify a minimum grade of 1/8 inch per foot. Both the plumbing codes I know of are going to specify the slope of the pipe depending on the size of the pipe. And we get into that, in code. But anything smaller than 2 inch is going to be 1/4 inch per foot. So that's not quite entirely accurate. They do give us some definition on the term drop and state that the drop is the total amount of distance where the pipe is out of level. So, level is obviously totally flat horizontal pipe. When it comes down, we have drop, and there's a distance there that we can measure, as we saw in the triangle earlier. Then it states, thus, at 1/4 inch per foot, the drop would be 1 inch if it continued 4 feet. Now, if you're going to remember anything from this chapter to save your life as a plumber, just remember that for every 4 feet, you go down 1 inch. That is ideal slope. It should be a permanent part of a plumber's memory. All right, have a look with me at page 124, and at the top it says formulas. They're going to give us 4 different formulas that we can use to calculate and either get the slope or the drop or other things that we need to know as we're calculating for the pipe. The first formula they give us, it says this is in inches per foot. We're looking for the drop, and it states that the drop is equal to the grade times the run. So the drop is the amount out of level in inches. Keep that in mind and pay really close attention here to the units. We have feet, we have inches. We have to know what we're working with, and sometimes we have to convert these in order to get the answer. Now this one's really easy. It doesn't take any converting. You just take the total horizontal distance, the run, times it by the grade, your slope, that you're trying to create, and that's going to be your drop. We have another formula here that is also in inches per foot. Let's say that we have the drop. We know how far it needs to go down, and we know how far it needs to go, but we're not sure what grade that would equate to. We can figure this out. Grade equals the drop divided by the run. Now it's important to note that the drop is in inches and the run is in feet. And when we divide that, we're going to have a decimal, and we can use that as a percentage. We can convert that into a measurement on our tape, whatever fraction per foot. But once again, that's what we're dealing with, is inches per foot when we're looking at grade or when we're trying to find drop. The next 2 formulas that we're given here are dealing with percent grades. Maybe we're not dealing with that fraction of an inch, but maybe I know my percentage. And we'll get that. You see that in code? You might receive that instruction from an engineer that says, give it 1% grade, give it 2% grade. We talked about that earlier in this unit as to how those convert back and forth with units of measure or just, hey, I've got my percent. But let's say I'm trying to figure out the drop. I know what the percent grade should be, and I know what the run is. How do I get my drop? They give us this formula. Drop equals the percent grade times the run, and then you divide that by 100 to get it into a percentage. What if I have the drop? I know how far down it's going to go. I have the run. I know how far it's going to travel. But I want to get that into a percentage instead of a fraction inch per foot. How do I get that? They give us this formula. Percent grade equals the drop divided by the run times 100. Now, there's an important note on this one, and that is that the drop and the run must be in the same units. If I'm dealing with inches, they have to both be in inches. If I'm dealing in feet, they have to both be in feet. So with this particular formula, the percent grade, I'm going to have to convert. Say I have like a drop of 6 inches, but I have 50 feet for the run. I've got inches and feet. I've got to convert those inches into feet, which would be a half of a foot. 0.5 feet is going to be my drop. So you can see that we're going to convert that when we calculate for percent grade. Let's go to the sample problems. 1A and 1B are dealing with the calculation for the drop. And most often as plumbers, that's what we're trying to figure out. You know, I can go measure out my distance, the run. I know what slope I'm going to be playing with because I'm going to install that. But how far down do I need to dig? Or what is the difference between my hangers? We're often figuring out for drop. So this is a useful one. 1A asks us, how much drop is there in 18 feet of run at 1/8 inch per foot of grade? So we use that drop calculation formula. Drop equals grade times run. We know both of those. Drop equals our grade, which is 1/8 inch per foot. And in this case, we can just plug it right in as inches, right? 1/8 inch per foot times 18. That's the run, my distance horizontally. And it's going to give me 2.25 or 2 1/4 inch. And that's what I'm usually doing in my head as a plumber, right? Of all the formulas that we see in this unit, this first one, the drop, is going to be the one that we use all the time. Okay, what if they give us percentage grade though? Let's go to 1B. How much drop is there in 18 feet of run at 1% grade? I'll pause here and point out that we're dealing with the exact same thing in both of these questions. 18 feet of run and 1/8 inch per foot or 1% grade is basically the same thing. But we're going to look at it different, calling it something different. So in 1B, we've got the drop formula using percentage grade. Drop equals percent grade times the run divided by 100. If we plug in our numbers, I've got drop equals 1 times 18 feet divided by 100, and that's going to give me 0.18 feet. Turns out if we go back to conversions, 0.18 feet is the same as 2 1/4 inches. But we've been able to calculate it differently, and depending on what math I'm trying to use or what I'm trying to figure out, maybe it's going to be better for me to have this in a decimal foot. If I'm figuring elevations, I'm going to want it in decimal foot. And let me just pause and give a little bit of a hint here. You're going to be doing that in the following units. We're going to deal with elevation and the difference between where a pipe is and where it will be. And we're going to be calculating with these decimal feet, adding and subtracting decimal feet. So put this in your back pocket. We're going to practice in this unit. Then we're going to be using these formulas in the following units as we calculate other things. The second sample problem has 2 parts, and in this one we're going to be figuring the grade. In these scenarios, we don't know what the slope is, and we've got to figure that out. 2A says, what grade to the nearest 32nd of an inch is a drop of 5 inches in 22 feet? So the 5 inches is our drop, 22 feet is our run. We go to that equation to figure out the grade. It is drop divided by run. And we can just plug these straight in for this equation. Grade equals 5 inches divided by 22. We punch that in a calculator, it gives us 0.227. And when we convert that into a fraction of an inch measurement, we get 7/32 of an inch. Let's pause here and I'll take you through the math on exactly how to do that as a refresher. If you're uncomfortable with conversions of feet or decimal feet to inches or to fractions of an inch, please go and review Unit 6. And I will even, for your benefit, include that instructional video so that if you need to go back and remember how that works, you'll have it. So there in 2B, we were calculating for grade. We took 5 divided by 22 and got 0.227 inches. We want to try and get that over into a fraction. So if I'm going to turn that into a fraction, I can take 0.227 and put it over 1. That creates a fraction, and it is what it is. Now, if I want to convert it into something, that means I'm not going to change the number, but I'm going to change how it looks. Now, if you remember multiplication, you can times anything by 1 and it's the same thing. With fractions, I can turn that into 1 over 1. It's the same thing. But if I change the way that 1 over 1 looks, they wanted 30 of an inch. So if I'm trying to go to that fraction and they say 30 seconds, I can do 32 over 32, which is equal to 1 over 1, which when I times 0.227 by 1, it's the same distance, but we're just changing how it looks. And what happens when we multiply this? Let's run it here. 0.227 times 32 equals 7.264 over 32. And we're talking inches. Now, that looks ugly. I mean, just ugly, because we still have decimal over fraction, and we're trying to get to a fraction. But this is where whenever we're converting to fractions of an inch, and we've done that multiplication to convert and get a denominator, that's the bottom part, right? Now I have something over 32 here. That's what I wanted. We just got to round this thing. On the top, we're going to round up or down, right? That's how we make this conversion. So 7.26, it's closer to 7. I'm just going to round down, and that's why in the book they come up with 7/32 of an inch. They've gone through this conversion process on that problem 2A, and that's how we come to 7/32 of an inch. Once again, if you need a refresher, make sure to jump back to Unit 6 and make sure you're familiar with and comfortable with those conversions. I know it's been a long time, over a year, since you messed with those. But you need to be able to convert fractions to decimals, decimals to fractions, feet to inches, inches to feet, and move freely back and forth between those as we're doing measurements. Take the time to make sure you're sharp on this. 2B asks us what percent grade is a drop of 8 inches in 60 feet. So here we have it spelled out in the sample problem. We'll use the percent grade formula, which equals drop divided by run times 100. Now please remember that in this particular formula, we have to convert inches into feet in order for the calculations to work. That's only for this percent grade formula. If they give us 8 inches, we convert that into feet by dividing by 12, and that gives us 0.67 foot. That's our drop. So then we plug this into our formula, and you'll have to excuse the textbook here. They messed this whole thing up when they printed this. Follow me here. Percent grade equals 0.67 feet divided by the run. Now the run was 60, not 100. That's our problem below here. For some reason, there's a random equal sign in here, so bag that. What we're really trying to get here is 0.67 divided by 60 times 100. And we can multiply that 100 to the 0.67 on the top part of the fraction. Because 100 over 1 is another fraction. We're just multiplying fractions. But in short, if we take 0.67 times 100, we're going to get 67. Divide that by our 60, and we get 1.1% grade. Sorry for the confusion of that sample problem, but that's how we plug it into that formula. Now it's your turn. You have some exercises. There are 8 problems. They're put into a table here, and your responsibility is going to be to convert or use those formulas and find the missing information. For example, number 1 is missing the drop and the percent grade, but you're given the 1/4 inch per foot grade and a measurement for the run. Now, some of these others you'd calculate for another missing piece of information, but you go and fill out the table using those formulas to calculate everything you need to know. So work those through. As you're doing it, refer back to the sample problems if you get confused about how to use the formulas. One last thought, I really do hope that you see the application for this. I hope that you become good at this. If you're not already using it all the time, when you're installing drainage pipe, when you're hanging hangers, drilling holes and digging trenches, this is where it's at. If you do the math correctly, you can save yourself over digging a trench deeper than you need to be. You can ensure that pipe going in to joists or other structures is going to have proper slope and it's not going to have problems. So we use this all the time. Hopefully you can see the application. Good luck with your exercises.